So in previous videos, we've looked at how to figure out the GCF or the LCM of two numbers. So this lesson, we're not going to exactly go over, this is how you find the GCF or this is how you find the LCM. We're going to be looking at word problems, all right? And instead of just saying, find the GCF of, 32 and 64, or find the LCM of 4 and 5, we're going to throw it into a word problem, which kind of makes it a little more real for the students. This is probably the hardest part of doing GCF or LCM. Once they figure out, is this a GCF or is this an LCM problem, they can kind of fly through the problem. So, GCF, just to remind us, GCF stands for greatest common factor, and LCM stands for the least common multiple. So, if we're looking at GCF, the greatest, we're going to be looking for words that mean the greatest or the biggest or the most, versus LCM or the least. All right, we're going to be looking for words that mean the smallest, the least, the minimum. So essentially what I have my students do is, especially it's great if they have highlighters, is read the problem one time before you do any math and find what is the key word in here. Which word do you find that means the most or the least? So question 1 here says, Mabel made snack bags filled with jelly beans. She used 32 green jelly beans and 48 yellow jelly beans. She used the same number of each color in every egg. What is the maximum number of snack bags that she could make? Well, as I read, I find that word maximum, which happens to be the most. All right, maximum most. So this is a GCF problem. All right. Reading the next one down, it says Mr. Reedy passed out a paper for his students on Monday. He gave every 10th student a green piece of paper and every 6th student a white piece of paper. What number of students received both colored papers first? Okay. Now, this kind of contradicts what we just talked about by looking for the most or the least, or words that are synonyms of the two. Now we're talking about, okay, we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here you go. Here's a green piece of paper. And then 1, 2, 3, 4, 5, 6. Here's a white piece of paper. So if we go, 10, then it'd be the 20th, then the 30th, and it'd go 6, then 12, then 18, then 24, and so on. That signifies if we're counting by every 10 and we're counting by every 6th, we're going to end up getting LCM. If I go down to my third problem, a costume designer has 36 bat buttons and 27 pumpkin buttons she must use to create costumes. What is the largest number of costumes she can make without having any buttons left over? Largest would mean the most, which is GCF. All right. Daniel has 40 Reese's peanut butter cups and 90 Butterfinger candy bars. He wants to make packages of these candies to bring to school and pass out to his teachers. What is the maximum number? All right. Once again, maximum number of packages. So that's going to be GCF. CF. Hot dog come in packages of 12 buns and the packages of 10 buns. What is the least number of packages of hot dog buns? Okay, well, least means minimum, or the LCM. LCM. Fix that L there. Okay. Next, we have Sarah has 16 red flowers and 24 yellow flowers. She wants to make a bouquet with the same number of each color flower in each bouquet. What is the greatest? All right, greatest, GCF. And then 2 neon signs are turned on at the same time. Both signs blink as they are turned on. One sign blinks every 9 seconds. The other sign blinks every 15 seconds. And how many seconds will they blink together again? All right, this is kind of like that problem up there with every 10th student and every 6th student versus every 9 seconds and every 15 seconds. And in this case, once again, we're going to be counting by 9s. We're going to be counting by 15s. This is an LCM problem. I hope this helps a little bit. From here, the students have a pretty easy time once they figure it out, because now they just have to find, 9 and 15, find the LCM of those, 16, 24, find the GCF, and so on. So I hope this helps.